welcome to another Big Brain Puzzles. I am MBW, the Megabit Warrior, and today we're going to be playing Sagitta? Sagitta. I don't know how to say that word. Speakeasy by Katie Splendor. Yeah, I can't pronounce things, so why'd you guys make me do that? But anyways, we're going to play this Big Brain Puzzle, and if you guys haven't seen this before, this series, basically I'm going to play a puzzle. It's a Sudoku variant puzzle for the first time, so it's going to be a blind, figure out the puzzle as we go. But I'm going to put the link of the puzzle in the description below. So if you want to play along or pause the video and play it yourself, see how long it takes you to do the puzzle. And if you want to see me and how my brain works to solve the puzzle, you can watch along. It's a lot of fun. And or you could just see, make fun of me and how long it took me to do such an easy thing. Because usually it's the one little thing that gets me. And then it ends up being like such an obvious clue, but it'll be fun. It'll be great. So I'm gonna go ahead and show the puzzle, and I'll go ahead and talk about the rules. But again, link is in the description. So if you guys want to play, it is super fun. I love these puzzles, and I try to do this every other Sunday. So sorry, my throat's gonna be a little the whole time, so I apologize. All right, so normal Sudoku rules apply, which means digits 1 through 9 in a row, in a column, and any of these 3x3 grids have the digits 1 through 9 that cannot repeat. And we are given no digits at all in the entire thing, so we have to definitely make sure that we know the other rule sets in order to play along. So modular lines. Oh, wait, I skipped one. The 9 green squares form a extra region containing digits 1 through 9. So these digits right here, it does look like there's 9 of them. Yeah, I don't know why I was thinking that they didn't have 9. They are digits 1 through 9 as well, so kind of like Sudoku, where they do not repeat. So if there's like a 1 right here, that means there can't be a 1 anywhere else. That's basically how we do that. Okay, modular lines. Any set of the 3 consecutive digits along a hollow teal modular line must contain a digit from each of the following sets: 147, 258, and 369. So in other words, this entire thing right here, if we determine that like there's a 3 right here, that means the rest of these digits have to have the other digits. So like it would be like 6 and then 9, and this is 6 and this is 9 and this is, so it would have to be the same digits across everything else. And it is consecutive digits, so that means it would have to be like, it would have to go in that order, like 147, 147, 147. So like it would do it like that. And that is like a 1 2 3 1 2 3 1 2 3. Yeah. So it has to be consecutive, it says. Okay, cool. Good to know. X and V sums. So digits separated by an X sum to 10. So right here, this, whatever 2 digits are in here, they equal 10. And then any that are on a V, like right here, have to equal up to a 5. No negative constraints. So there's going to be no negative numbers. I think that's kind of obvious, but just in case. All right. And then the dots. So the black dots have a ratio of 2 to 1. So if this is a 2, then this can either be a 1 or a 4. Digits separated by a white dot right here are consecutive, so difference between 1. So if this is a 5, that means this can only be a 6 or a 4. And that is all the rules. Yeah, so that's all the rules. So we're going to go ahead and get started. So let's go ahead and put the timer on. And again, play along, do all the things. Comment, please like, please, for the love of God, like this. Like me, thumb me. Come on, guys. All right, so let's go ahead and play. All right, so first things first. I don't know why. I always like doing the black dots to just label them, just to kind of show what numbers that they can be, because it has to be a 1 to 2 ratio, right? So the only possible solutions are these digits. And I like to just put that on there just because I know that there's never going to be a 7 or a 9 or anything like that. So just bear with me. That's all I wanted to put. That's all I wanted to put. The next thing I want to do is I actually want to see about the V's. Since the V's are basically going to be low numbers because it has to equal 5, it has to be the digits 1 through 4, right? So I'm going to label all the V's. You're not a V. You're not a V. As 1 through 4. Because again, it's either going to be 1 plus 4 or a 2 plus 3 to be 5. This one in particular, this one is showing me that this is always going to be a high number. So whatever number is here, so if it's a 1, it's a 9. If it's a 2, it's an 8. If it's a 3, it's a 7. If it's a 4, it's a 6. So we know that these digits are going to be that. We can also say the same thing for this, right? So perfect. So perfect. Let's see, other than that. I don't want to label anything here, so I'm going to leave the X's alone. And the consecutive ones, we don't have enough detail in order to do that. So what I want to do is I want to see what can go here, because they have to be the following digits. It has to be 147, 258, or 369, right? If it was a 3, for example, it would have to be 369. So like if any of these are a 3, that means this would have to be a 6 or a 9. So it automatically can't be a 3. Same thing with this. So it automatically cannot be a 3. What about a 4? 1, 4, that works. What about a 2? 2, 5. And 5 does not work. And 8 obviously doesn't work. So, wow. That's crazy. So we know that this whole entire line is the 147. That is crazy. So we already kind of know that these are going to be 7, because it's consecutive. It has to be like 147, 147, 147. So in other words, all these are 7. 1, 2. Wait, that can't be 7 though. What? Hold on, that doesn't make sense to me. Am I doing this wrong? Any set of 3 consecutive digits. Does that mean that it doesn't need to be 147, 147? It can actually be, like, say for example, I could put a 7 here, right? And then as long as it has just the digits 147. I was reading that like any set of 3 consecutive digits, but it doesn't sound like it needs to be consecutive, because it's impossible. It's impossible because basically, if it is consecutive, I just want to label it in a color just so you guys see it. If it is consecutive, and this is regardless if it's 147, 258, 369, if it's consecutive, they land here, right? Well, the same digit can't be in the same row or same column or row, you know, whatever. So that means, yeah, they can be placed anywhere. That's interesting. Okay. So in other words, we don't know if this is going to be a 7. Well, actually, we do know, because there is a 1, 4 here. So this has to be a 7. And then, of course, this right here. Wait. I like messed up this entire thing, didn't I? This can never be a 10. Oh wait, no, 1 plus 9. Okay, never mind. But it can't be a, oh my god. That's what I was doing. Okay. You see how I like just mess up all the time? Why did that go away? My bad. Okay. Let's go backwards. My bad. Am I not understanding this rule set very much? Like, any set of the 3 consecutive digits must contain a digit from each of the following. Oh. I read the rule wrong. Okay. I was thinking this entire time that this was that it had to be like 147, 147, 147. I am so sorry if you guys were playing, paused the video and started playing, and I told you the wrong rule set. I apologize right now. I didn't understand what it was saying, but I think I now understand, because it doesn't work. Like, it doesn't work if I do it that same route. So what I think it's saying now is, if this is a 147, the next one would have to be a 258, and then a 369, and then a 147, and then a 258. Like, it basically goes around and says that digit just has to be one of those 3. That's the reason why I was a little confused on why I was saying consecutive digits. I was like, I don't understand, but it's that set is consecutive. Okay, so now that I know that rule, let's approach this puzzle a little bit better. Okay, so these are all still the same. What we can say is this can't be a 1 or a 4, because it would have to be consecutive, and we already said that. Now that we know the rules better, a 147, like, it has to be or the 1 and the 4 is in the same set, so it has to go to the next set, which that doesn't work here. So in other words, these two are basically a 2-3. That's the real way around this. So this is a 2-3 portion. Now, I guess we can label these. So that means this is either going to be a 7 or 8, either of these. Because this is a 2-3 and it has to be consecutive, I can therefore say that this is going to be a 7, because this set is either the 369 or it's the 258. Either way, both of those get used, and so this one's going to be the consecutive number of 147. And so since this has to be 147 as well, 7 is the only one that works. So 7 and I'm not going to label it there. But yes, there. And so this can only be a 1 or a 4. So let's go ahead and get rid of the rest. Oop. Did I mess it up? My bad. Okay, this can only be a 1 or a 4. Right here. And what we don't know is this has to be a 248 or a 369. I'm just putting them there. But these 2 3s right here means that these two are never going to be a 2 or a 3. So it's going to be one of those. There we go. This looks a lot better. This looks a lot better. All right, we know that this is not going to be a 3 or 6. This is never going to be a 1 right here. It could be a 2. It can't be a 4. So this is always going to be a 2 or 8, which is one of the sets. So this one's either going to be a 1 4 7 or a 3 6 9. I wonder if I should label them, like anytime it's in like a particular set, like these are the blue ones. Actually, I am going to label it. Now that I'm doing this, I'm like, that's definitely going to be very helpful. So this is that color. I don't know. It's like whatever color that is. And then yellow. Okay. We don't know over here, so I'm not going to label them just yet. But now I can say that these are all going to be the same color. And these are all going to be the same set color. And then these are going to be the same. So if I'm looking at this, is there any digits that are not supposed to be there? So, no. So we're fine here. We're fine, guys. What we can say too, though, is since this is a 2 3 2 3 2 3, that means this is not a 2 or 3. Well, this is not a 2 or 3, and since these digits have to equal 5, that means these can't be 2 or 3. So we have the 1 and 4 here, meaning across all these, the 1 and the 4 are taken. Actually, I want to label this just because of that. In other words, this is where our 5, 6, 7, 8 go. Ooh, this is cool. Because this is where our set, like our 6, 7, 8 go, right? 7 has to be in one of these. Has to be. Interesting. Okay. Could be here, though. That's the trouble. That is the trouble. I don't yet want to touch that. I'll do it in a second. Okay. All right. Anyway, sorry about that. 2 3. Let's go to this line because we haven't really touched this line too much. So a 2 3. They see each of these. That means 7 is in the 1 4 7. So this could never be a 7. Because again, this one sees this one sees that one. And that means that the 7s can't be in there. So this is not 7s. So that means this is actually our 7. Which means there's a 7 down here. Which means there's a 7 down here. 7 somewhere, I don't know. Okay. So I want to say the same thing as here. This has to be a 1, 4, 7. So I'm going to put 1, 4, 7. This can't be a 7. So we're going to get rid of all those. I'm going to do that as blue again. And then this, yeah, actually it has to be 2 or 8 because of that same logic. So that means we definitely see that. This is still unknown, so I'm just going to make this pink. We don't know if this is going to go a 1 or 4. Or 7. I mean, like the, you know what I mean. Or 3, 6, 9. We still don't know that. This, these touch each other. So actually these touch each other too, right? They do. Interesting. Can this be a 9? It can be a 9. Why didn't I label a 9? I don't know why I did that. Okay. Damn, because I was going to say something, but then it's just because I mislabeled it. All right. All right, so what can I say now? What's interesting, and maybe I'll just label it. Should I label it? I think I have to. It might be the same here, now that I think about it. What I was going to say was... these would have to be like these two. Would have to be a 5, 6, 8, or 9 as well. But we don't know if the rule set says that we can't repeat. Like, say, for example, if this is a 2, this can also be a 2. Because it says any set of the 3 can, like, it doesn't say that the numbers have to be used. So it just says must contain a digit from the following. So yeah, it can still be, like, this could be a 2, this could be a 2. Like, if this is a 2, I mean, then this can also be 2s, so. Okay. Then never mind. Damn. Okay. Well, let's just do this. Okay, so we know that this is going to be a 2, 5, or 8, right? If this is a 2, oh, you know what? They both see this. So let's see if this, let's end this one, actually. Let's just see this. If it was a 5, it would mean that these would be 6 9s because it's both seeing that. If it was 8, these would both be 6 9s. I'm not seeing any issues with that, so that works. This could be a 2 as well. Oh my god. Oh, no. Sorry. These things are preventing it from being, because the 2 3s have to be there. Okay. That's why I got to this. Okay. But again, oh, that's right. Okay, this is how it is. So these two numbers right here, if it's a 5, it's seeing both of these, meaning this would have to be a 6 9, because since they're on the same line, they have to be the same sets. So if this is a 5, this would have to be a 6 9, and it can't be the same digit because it's on one of the green ones, which means it has to have an extra region. So it can't have duplicate numbers, in other words. So if this is 6 9, this cannot also be 6 9, because again, you need digits that are different. Therefore, this can never be a 5 or an 8 because of that logic. Same thing here. These have to be 2s because that's the only way for it to still be able to have a 5 or an 8 in these 2 digits. And we need all 4 of those digits to be labeled here. So these are a 2. And since that's a 2, this is an 8. Oh, shoot. It's not working here, though. Oh, my God. That didn't work. How didn't that work? I thought my logic was good. I'm a little confused now. Because again, we know that these are 2 8s. And we know there's a 2 8s, or 2 8. So this has to be 2 5 8, both of these. If they're 2s, there's no way that both of these can be 8, so it can never be 2. Let's just label that. It can never be 2. How do I do this without... Let me see. So let's just say this is the 2. So then this has to be like the 5 8, right? I mean, this can still be... So if this is like a 5, this would have to be 8. This would also have to be 8. Oh, but this can be 8 still. I was thinking of it too messy. No, that can work. Got it, got it. So it actually still works. That could be a 5 or 8. Interesting. So again, one of these have to be a 5 or 8. So the rest of them will be 6, 9. Super interesting. Okay. Let me move on for a second. I'm going to label these really quick, just like I did on the other ones. This is going to be a 2, 3, 5, 6, 8, 9. Again, it can't be 1, 4, 7. So here, it can't be a 2, 5, or 8, so I'm going to label, it can't be a 7. It's going to be one of these. In which this is also going to be one of these. Actually, I might as well just label them all. Okay, the 7 sees that, but 7 doesn't see this, so this could still be a 7. Interesting. This can never be a 9. These 2 can't be a 9, because there's no 8 here. Since this can't be a 2 ever, very super interesting. You know what? I just thought of something that I should be labeling. These 2 can't be the same. And again, I don't know if it's going to be the pink, like which one it is, so I'm going to label these the same way. But these yellow ones, this has to be yellow because, again, whatever this is, this can't be. So if this is a 2, this would be a 3. So I can say that this is true. And then this is true. Therefore, I actually still feel like these could be still 2 3s. Now that I think about it. God, this is tricky. I just don't want to like mess something up. You know what? I'm just gonna label these just in case. This can be like a 1 or 4 over here. Oh wait. The 1 and the 4s have to go here, but look at this 1 4. Like both 1 4s can't be up here because then it would cause this to. So this is always a 1 4. That's interesting. I almost want to just label it that just so we could see like, oh look, there's this is already on the line. Actually, that's true, which means this has to also have the 1 4 or 7. In other words, all I'm trying to say is either the 1 or 4 has to go here. Just don't know where. Can we do the same thing with this? This goes here. We don't know this is a 7, so actually the 1 or 4 can go still here. Because we don't know if this is a 7. But we did over here. Wait. I could have put this in the entire time. Oh my god, guys. See, I told you guys. I told you guys you were going to see this puzzle and there was going to be something obvious, and we could have did that super early. This is not a complicated puzzle now that I'm looking at it. Now that we broke that, like the puzzle's basically gonna flow. Like the other stuff that I was trying to figure out right now, it's like we were actually intelligently like logicking this around, but like we didn't need to. That's so horrible. That entire time I could have put the 3 there. I could have put the 3 there. Wow. Okay. All right. Well, let's do the puzzle, guys. Oh my god, I'm gonna beat myself up later. Okay. So because that's a 3, this is gonna be a 2, and that's gonna be a 3. What I want to do actually is I'm actually going to label these the correct color. So this is gonna be our yellow, which means this is gonna be our yellow. And then this is going to be our orange, which means this is going to be our orange. Oh, wait. Sorry. It's always yellow. Let's not mess this up, Michael. Okay. I just wanted to show that just because, like, again, it will flow. Anyways, we're going to clear up all of the yellow, in other words, and make sure that it only has a 2, 8, and 5. So, in other words, we're going to get rid of the 3s. We're going to get rid of the 9s. We're going to get rid of the 6s. And that's it. Okay. So these 5 8s see this entire thing. Perfect, perfect. Again, let's go ahead and get rid of that. Okay. So this is the 369. Wait, why can't it be a 3? I don't understand. I don't know. Same thing here. It's gonna be a 3, 6, or a 9. Why is it saying that this can't be a 3? I don't know why I'm not seeing why that can't be a 3. Am I missing something? I have no idea why it's telling me that. So I'm just going to keep it there because I don't know why it's yelling at me like that. Stop yelling at me. Okay. All right. So now that we got all those numbers and failed completely with seeing that, let us figure out. Oh, actually, 2, 3. Oh, these are all like that. Oh, that's why the 3 is not there. I was literally just doing the math right now. Again, these green, it's just because I didn't see the color again. These green ones, these green squares, can't repeat. So, of course, that can't be a 3. Yeah, I think I was just highlighting it, and I just didn't, like, notice that what I was doing. Anyways, so that works there. Good. Okay. All right. So that's our 8 because that has to equal 10. 2, 2, 2. So there's a 2 here. I mean, 2 is going to be up here. No 2's here, so 2's right here. 2's right here. Two. And 2 can kind of go anywhere here. Okay. I don't know why I wanted to label that. Let's see what 3 is right here, because I see this is like seeing all that. It's all that. Okay. So 3 is going to go somewhere here. 3 is going to go here, so that means there's no 3 here. Same thing, 1, 4. That means there can never be a 1, 4 there. So this, this is, so that means this has to be this 3, 6, 9, which is the color of this. So that means this has to be a 1 or 4. Perfect. Yes. Yes. Okay. Great. Great, Scott. Okay. Consecutive. That means that this can't be an 8. Could be a 2 or a 5 though. But now the 2 and 5s are seeing this, so the rest of these cannot never be a 2. And then this is seeing that, so that's a 1 or 4 as well. Like how it's actually like filling up everything. It's perfect. Ooh, we can kind of, since we see these digits, we can kind of like fill in what this is going to be. So it's never going to be a 1. Never going to be a 3. Could be a 4. But it can't be a 6 or it can't be a 9. So this is always a 4. Ooh. Ooh, Chavo. I don't know. Why is that in my head? It's definitely the ooh. Ooh. So this is going to be the 369. That means that's never going to be a 7. All right. So the 4 is seeing both of these in the grid and the row, so that can never be a 4. This 4 is seeing up here, so this is going to be our 1, which means that this is our 2, and this is our 3. Excelente. Excelente. I'm trying to delete. Okay. 1. So this is gonna be our 9. This is seeing that 1 over there was seeing this, so that goes here. That means this has to be our 1. I'm just gonna clean up a couple things. This is gonna be our 5. We don't know this yet. We don't know that yet. Okay. All right, let's see if we can get down here. So let me see. 1 is seeing all these. So that means 1 is going to go here somewhere. 1 is seeing these. I thought I highlighted that. That didn't work apparently. Okay, what about 8? 8 is seeing this. It's seeing that. So there's an 8 here. 8 can only go here, so this cannot be an 8. So that means the 8 is gonna be in this row or column, I mean. Except the 8s are on this row right here, so this could never be an 8. So that is the only place that an 8 can go here. Wow. Wowee. 8 could go here, which means we don't know. Well, actually, this is seeing that, so that means the 8 has to go somewhere here. Because of that, this can never be an 8, so this is going to be our 5. So that's our 8. That's our 5. We still don't know this one, so I'm going to leave that. That doesn't look good. That doesn't look good. Oh, no. Am I saying that this has to be the same number? Oh, no. No, it doesn't need to. It doesn't need to. This can be a 2. No, I didn't mean to label that. This can be a 2. Yeah. I don't know why I didn't label that. Why didn't I label that? Oh, when I was doing the thing. Was it that? That the reason? Yeah, let's go back a little bit. Because the 8, I mean, because this could be a 2, that means 8 can still go here. And I don't want to accidentally... Sorry. Man, I was going too fast apparently. Yeah, okay. That works better. This can also be a 2. Yeah. Yeah, okay, all right. So this is the same number. Reason why I know that is because this is seeing this. So like if this is a 5, this would have to be an 8. And since it's in a square, that means it has to be different from here. So that means if this is 5, this is 8, and then this is 8. If this is the same number, this sees this entire row. This sees this entire area. So this is the other 5 or 8. But the 5 is seeing that. So this is an 8. Meaning this is our 8s. Meaning this is our 5. That's our 2. That's our 2. That's our 8. 2. Wow. Okay. 7. 7. 11. This is a pretty good puzzle. I actually really like this puzzle. Oh, this is a naked single. Get it. So naked. This can't be 5, so this 5 has to be in this row, and it's going to see that because the 5's are right here. Okay, so what does this have to be? Was this all 3, 6, 9? So 3 seeing this. This is a 6 or a 9. And this is a 3, 6, or a 9. 9 is seeing that. Okay, that is working. Nines are still not like labeled. What about 4? 4 is down here. Oops, sorry. 4 is down here, I mean. 4s are seeing that, so 4 is here. Oh! Duh, this 8 is here, so we could do this. This is the 4. I was looking at the 4 here, and I was like, wait, there's a freaking dot there. What the heck am I doing? What the heck am I doing, guys? So that means the 1 and 4s are going to be here. Is this the 3, 6, 9 as well? That's so funny. Well, this is a 6, 9, definitely, because the 3 is seeing that. So that means the 3 is here. So that's our 3, that's our 6, that's our 9, that's our 3. 1 is seeing that. Don't know where the 7 is quite yet. 4 was seeing that. 7. 7's coming up here. I mean, this is our 7. What is it? 1 and 9? Yeah, it has to be a 1 because of that one up here. Okay, this can't be 5s here. So this is where our 5 is going to go. So that means this has to be a 6 or a 9 right here. Meaning this is either a 1 or a 4. 1 is seeing that, so this is our 4. That was clever on why that was there, because it kind of breaks the entire thing now. And I think the rest of it's just Sudoku now, so that's perfect. Oh my god, well that was a fun puzzle, like really fun. I definitely messed up as always. Like I feel, do I mess up like on every freaking puzzle lately? Like I had like a good run going, and then like all of a sudden I just start sucking at every which way, apparently. I don't understand what's going on. I feel like I'm just like, am I moving too quick? Like, is that what it is? I'm not sure. But this puzzle was really good. Hopefully you guys took a look at it, and you guys probably got better than my score. What is this? 3 and 5. There we go. And that's the puzzle. No, yeah, I really enjoyed this puzzle. I spent way too long knowing that this is 7 in order to get this to 3, because I was like trying to do some logic between this, and it was actually coming along. I actually feel like you could solve it without that being there. But then once I saw that it was like, oh wait, of course this is going to be a 3 because I have the 7 there. I don't know why I didn't see that X, or just went over my head. I don't know what the hell. I did the same thing a little bit later, like that black dot right there. I was like, we could have put the 4 in a long time ago, like so that this could be the 4 and the 1. And then from there, like everything kind of just like started flowing and everything like that. I'm like, man. And I know I messed up the rule in the very beginning, which is kind of why it took a lot longer. I didn't quite understand what it meant when it was saying like the consecutive digits and then these digits. I was like, oh, I thought it was like you had to repeat those ones and whatever. Anyways, all that to say, we finally got there and we did it. So very proud of us. But hopefully you guys had a good time, and I hope that you guys do another big brain puzzle soon. Again, every other Sunday we do these puzzles. I think they're a lot of fun. Hopefully you guys are enjoying them too. So like if you like, subscribe to subscribe. Of course, this is more of like a video game type channel and stuff like that. I feel like this is like the same genre a little bit because it's basically puzzles, and games have puzzles and stuff like that. So like, I'm hoping that you guys are enjoying this. But again, like if you like, and I will see you guys next time for another big brain puzzle. I'll see you later, man. Blah!